might join, but I'm not sure about it.
You're not sure. Okay.
Yeah, it was very early in the morning.
Yeah, I do understand. Hi, Ramesh sir.
Yes, ma'am. Welcome, ma'am. Welcome, ma'am. Welcome our guest today. Actually, I am standing nearby the Sustainability Center in Anna University. So,
That's so great.
so this is the backside of me. That is the one plastic recycled. It is a plastic recycled one.
Oh, okay. Nice art installation.
Okay, right. So we are having IEA program today.
Sir, sorry for the delay. In the sense, live started, sir. And also, I need to leave because I need to go to hospital.
Okay, okay. You can give the Niranjan. You can contact Varun and ask Varun to give the co-host to Varun and all the people. Kanagaraj also.
Okay, sir. Okay, sir.
We will wait for Ramalada ma'am. Just wait for 2 minutes.
It is raining here in Chennai and Coimbatore and all places. It's flooded, Anisha.
Yeah, I was checking the news. It seems
Yeah,
like it's a bad situation.
it's so
Yeah.
bad in Tamil Nadu right now.
Yeah.
Did you send? Kanagaraj sir?
Yes, sir.
Okay. I think after Ramalata ma'am joins, we'll start.
Yes, ma'am. Ma'am can't join, ma'am. That's why ma'am is discussing. I'm talking with ma'am only, actually.
Okay, okay, okay.
Yes.
சரிங்க சார், நீங்க ஒன்றும் ப்ராப்ளம் இல்லை, இப்போ ஸ்டார்ட் பண்ணிடுங்க. ஏன்னா அவங்க ஸ்பீக்கர் வெயிட் பண்ணிட்டு
Yes,
இருக்காங்க.
madam. Wait பண்றாங்க. Yes, madam.
என்னாச்சு ராமலதா மேம்க்கு?
மியூட்ல இருக்காங்க. நான் கூப்பிட்டேன், அவங்க வெயிட் பண்ணி
கனகராஜ் சார்,
லிங்க் உங்களுக்கு போயாச்சு.
கனகராஜ் சார்,
yes,
லிங்க்
ma'am.
அவங்களுக்கு அனுப்பிச்சாச்சுன்னு சொல்லுங்க. அவங்க
link வந்துச்சு,
யூடியூப்
madam.
லிங்க் இல்ல
இல்ல,
யூடியூப்
madam.
லிங்க் பாத்துட்டு இருக்காங்க. அவங்க
இல்ல,
ஜூம் லிங்க்
அவங்க
இப்பதான்
ஜூம்
அனுப்பிச்சிருக்காங்க.
கிளிக் பண்ணாங்க மேடம். பட் ஆல்ரெடி டீம்ல இருக்கு மேடம், உள்ள இருக்கு. அவங்க ஆக்சுவலா லாகின் சப்ஸ்கிரைப் கேக்குது போல.
சப்ஸ்கிரைப் பண்ணணுமா?
ஏதோ உங்களுக்கு வருதுங்கறாங்க. யாராவது ஒருத்தர் கொஞ்சம் கனெக்ட் பண்ண சொல்லுங்களேன் மேடம். அங்க யாராவது இருந்தா, ஸ்டூடண்ட்ஸ் யாராவது இருந்தா.
இல்ல சப்ஸ்கிரைப் எல்லாம் வராது. அப்படியே அந்த லிங்க்ல ஜாயின் பண்ணிக்கலாமே.
அதான் மேடம், இது
நீ லிங்க் திருப்பி ஒருக்க அனுப்புங்க. வேற ஏதாவது லிங்க்.
கனகராஜ்,
என் போன் அட்டெண்ட் பண்ணுச்சு.
கனகராஜ் நீங்க போன் கட் பண்ணுங்க. ராமலதா மேம்கிட்ட நவீன் பேசிக்குவாரு.
மேம், நவீன் சார் உங்களுக்கு கால் பண்ணுவார் மேடம். நவீன் சார் உங்களுக்கு கால் பண்ணுவார்.
உங்களுக்கு லிங்க் நான் அனுப்பிச்சிருக்கேன் பாருங்க மேம். அதை ஜஸ்ட் உள்ள போனீங்கன்னா வருது. வாட்ஸ்அப்லயும் உங்களுக்கு உங்களோட சேட்லயும் அனுப்பிச்சிருக்கிறேன், அந்த குரூப்லயும் அனுப்பிச்சிருக்கிறேன்.
வெல்கம் மேம்.
Welcome, ma'am. Yes.
Okay.
Good evening to all. I would like to start. So I would like to welcome all the people for this IGEN-iExplore Sustainability Research Lecture Series 3. So I welcome Dr. Agila Muthuramlingam ma'am to give a welcome note.
Yeah.
Yes, ma'am.
Thank you, Dr. Kanagaraj. I welcome Dr. L. Ramesh, the president of the Institution of Green Engineers, and Dr. Ramalata Marimuthu, founder of IGEN-iExplore Foundation for Sustainable Development. Dr. Kanagaraj, who will be giving the vote of thanks, and he is the assistant professor in EEE from SRM Institute of Science and Technology. And I welcome our guest, Ms. Anisha Paul, scientific ML engineer, Planet AI, for this IGEN-iExplore Sustainability Research Lecture Series number 3. Now I request Dr. L. Ramesh to give the opening remarks of the program.
Thank you, ma'am. Thank you so much. It was very happy note. So this is our first program in association partner with IGEN-iExplore Foundation. So previously we would like to host only IGEN, and this time we had collaborated and we are hosting, and this is the third lecture on sustainability. It is very happy that IGEN having several vertical. In one vertical we are having IGEN Innovation Consortium. So through that innovation consortium, the research and innovation activities are there. One of the part of this innovation and research, we had initiated the IGEN, that is a research lecture. What it means is that we need to promote this research essence to particularly to the young students, so that in future we need to convert them, motivate them for the research activities. You all know that the present students not very much motivated for the research, because I directly daily involving students activities. Whenever we will ask, they will tell 95% they want to go to some company and get some salary. That salary also they need 1 lakh per month when starting itself. This is the psychology of the students. And that psychology, some 10% or 20% we need to change it towards the research. So when we ask them when we have to move to the research, then a lot of restrictions is coming. No, sir. No, we want to get money like that. But research is a real contribution that we need to take it forward. This is the first start. Through this, we are planning to go ahead with all other activities like that. So the first part, we are taking the top experts. That is what we had, the international experts, particularly for the forum. So only the international experts we will and connect with the people. And we had created a separate WhatsApp group and connecting all the participants, research lecture 1, 2, 3 in the same forum. And we are going to identify the research team from this forum. So that is the idea. So the research team from this forum, we can integrate that research team with the industry. Maybe our chief guest today will have good participants, good researchers from this team itself in future. So they can collaborate and work. That is what the outcome we need to get it from this lecture. It is named as a lecture, but the motivated plan is like that. So slowly we can take it this forum like a what in international project like that. Some project we need to take, and this is the objective. So thank you so much, Akila ma'am, our secretary, and who is taking lead and coordinating all the activities. And special thanks to Ramalada ma'am, and a popular figure in IEEE, and now having his own concern and so for society activities and sustainability society activities. I am very happy that SDG 17 is working well. Partnership for the goals. So that I always admire the UN people. But a lot of people are telling that all whatever it is, but the UN people done fantastic job. 16 goals. Only possible 16 goals to achieve. If 17 goals in action, then only otherwise there is no need of going that. That is what we all are connected here, and several institutions also connected here. So good news today, this message we communicated to the Green Day participants. We had 60 institutions in India, including Chandigarh University, like that. Most of the members now watching the program in our YouTube channel. And thank you so much, our guest Anisha Paul ma'am, for accepting our invitation and be part of that. And we are like to travel with you in all our activities towards the STG and towards green activities, ma'am. Thank you so much, ma'am.
Yes. Next, I would like to welcome Ramalada Marimuthu ma'am to give a speaker note.
First of all, I would like to welcome everyone here, the chief guest, the organizing committee, and also our participants who have joined through YouTube. This is a wonderful lecture series, which was initiated by Dr. Ramesh from IGEN and supported by Akila ma'am, Kanagaraj sir, and IExplore, of course. This is for bringing out the basics, the understanding of the basics, and also for bringing out the researchers to invest their time in climate change, because many of the people, they don't even think about the climate change as a possible research area. And I believe that it's the most popular thing right now, and everybody will be able to find some area where they can do the research and also contribute something to the world's next generation. And in that regard, I really respect Dr. Anisha Pal, who has been a scientific ML engineer in Planet AI, which is a startup. I actually met the owner of Planet AI, the founder of Planet AI, Kalai Ramya, in the airport, Bangalore airport, when I was traveling somewhere and she was also traveling somewhere. We were not going to the same destination, but somehow the destiny was like that. So we met and we talked and found that we had the same interests. And because of that, we kept connections. And she also gave a lecture on the AI possibilities, the working possibilities of AI in climate change for my climate change series last year. And this year, when I asked her whether she will be able to do the same thing again, she immediately referred Dr. Anisha Pal, and she has a lot of high regard for Anisha Pal. I can see why. She has pursued her master's in Georgia Tech, and after that, she has been in various areas. She has been working on computer vision, geospatial applications, climate forecasting, sustainability, and she has been working in the Center for Quality Growth and Development. It is a GIS-based community decision support tool, and these are all the small things that she can actually talk about. And she is a machine learning engineer at Hyperverge. She has been a machine learning engineer at Hyperverge. And after that, she has joined Planet AI. And during her free time, she is such a vivacious fellow. She finds climbing, trekking, hiking, reading, everything of interest. And today, definitely, whatever you are going to talk about the AI, I'm sure all of these activities will also have an influence over the research, and you will be talking about that, I believe, Dr. Anisha. Welcome to the lecture. Thank you very much.
Thank you. Thank you for the introduction. So I'll present. So today's lecture will be about from AI to climate action, and how to harness basically a machine learning background for environmental impact. So let's start. So I would like to emphasize that the main agenda of today's lecture is to give people an idea of one of the many realizations on how to incrementally translate from a pure AI background towards AI for climate change. And I would also like to stress on the point that this is not an exhaustive coverage of all the climate plus AI applications out there, but an overview to intrigue interest in this particular area. So the overview of today's talk will be walking through my journey, and I will interleave these following components as we walk through it: a brief introduction to different branches of AI, AI for remote sensing and sustainability, applying AI for climate forecasting, little about climate connections, how to make those connections so that you can work on such projects. And that would be the overview of the talk. So a little bit about me. I did my bachelor's in ECE from Manipal, And from there, I went on to start my first job as a machine learning engineer at Hyperverge. And then I proceeded to do my master's in computer science. And finally, I'm here as a scientific ML engineer at Planet. So during my initial undergrad days, my main focus was image processing and computer vision. I dabbled with different projects in this area. And through this, I explored this particular area and garnered an interest. So with that, let's go into a brief introduction of what do I mean by computer vision, what is AI, and how to look at it. So if we look at this Venn diagram, then you'll notice that not all machine learning is artificial intelligence and not all deep learning is machine learning. So what is artificial intelligence then? So the broader definition is that it is simulation of human intelligent processes by machines. Whereas machine learning is algorithms that incorporate intelligence into machines by automatically learning from data. So artificial intelligence composes of expert systems, which are like systems where like they use knowledge and rules to make decisions about how to create simulations of human intelligence. Whereas machine learning is mainly based on the fact that we should be able to develop algorithms that automatically learn from data. And deep learning is a specific area in machine learning, which is inspired by human brain neurons and generally involves very complex and deep networks, hence the name deep learning. So let's also focus at these three areas within machine learning that will help us understand the different ways in which to learn from data. So the first is supervised learning. So supervised learning, we can think of like we are giving the model both the question and the answer. So it learns to understand the underlying data distribution and what data will go with it. In unsupervised learning, we just throw a bunch of data at the model and tell it to figure it out all on its own. So it starts identifying patterns that match. Like in this case, the robot is basically able to understand that the two squares will go together and the two cylinders will go together. Whereas in reinforcement learning, the model goes through a sequence of feedback and rewards where it learns by making mistakes and correcting itself based on the feedback. So let's say the model or the agent is going in the right direction, we give it positive reward. Whereas if the model is going in the wrong direction, we give it negative reward. So the goal of this particular algorithm is to try to maximize on the reward, and that's how it learns. So the basic overview is supervised learning, which is mainly task-driven, unsupervised learning, which is mainly data-driven, and reinforcement learning, which is algorithms that learn to react to that environment. Going a little bit deeper into each of these areas and further categorization, we come at supervised learning, which can be further classified into classification, which basically means categorizing the data into a particular bucket, and regression, which you can think of as predicting a raw value, such as what one will do with forecasting problems. Like, given the temperature for the past 30 days, what will the temperature tomorrow look like? Similarly, for unsupervised learning, we have a breakdown into clustering, which basically putting patterns that match in the same cluster, and dimensionality reduction, which is a method of representing a given data set using a lower number of features or dimensions, while still capturing the original data's meaningful properties. And then finally, we have reinforcement learning, which has mainly significant applications in robotics and game agent design. So with that, we come towards computer vision. And this was the area that most of my work has been in. And you can think of computer vision as an intersection between signal processing and artificial intelligence, where the idea is to understand from visual data and help models to basically make decisions based on that. So moving on, there are multiple areas within computer vision. Like this is a graph which was taken in 2020 from CVPR publication submission. And as you can notice, there are so many different fields within computer vision, and there are so many different subfields. And most people focus on one, like if you look at one person's research, they'll focus on a few of these fields and will go dive deeper into it. But during my undergrad days, because I was exploring this field, I picked a few areas and I explored those. And it is also something that I'll strongly suggest for someone who is doing their undergrad. If they're interested in research, if they're interested in any field, to look at the different areas within that field and play around with projects in different segments of it. That is the best way to learn. Like I feel that is one of the best ways to learn where one has interests in. So this was during my undergrad days. And as I mentioned, since I played around with a lot of things, I found a little area where I was most interested in. And I got introduced to this area through my stint as a machine learning engineer at Hyperverge, where I took my experience from computer vision and tried to apply it to geospatial data. So let's dive into what is geospatial data. And the answer lies in the name, where it is any data that provides information about any geographically referenced locations. And the most commonly known geospatial data is satellite imagery. And usually when one Googles satellite imagery, you will see an RGB image like so. But that's not all that there is to it. It is made of multiple bands based on which satellite captured the imagery. And each of these bands helps scientists decipher different data that won't be possible with just RGB data. For example, if I were to detect polar bears on ice, RGB imagery won't suffice, like white and white won't go together. But if we're to use thermal infrared imagery, then it's a much simpler task because now you have a warm body against a cold body of ice. So is satellite imagery all that there is to geospatial data? And the answer is no. You can have climate data, GPS data for location tracking, and many other forms of geographically referenced data. And all of these data points can be layered together to create a depiction of the real world. And these data points can be further categorized as raster data and vector data, where raster data is mainly you can think of as images which can be organized into a grid, whereas vector data is points, lines, polygons like Google Street View, land parcels which have like polygons, like for example, the buildings and all of those. So moving on to my experience at Hyperverge, I worked on AI-based infrastructure change detection system. And the goal of this system was to detect changes in buildings using aerial imagery data, match them with county records or permit information to find defaulters, which enabled the county to catch property tax evaders. So let's dive deeper into how this model was built from start to end. So let's start over here. But before this, a lot of pre-processing was done from a geospatial side, which is a whole other like can of worms on its own. And we arrived at these like two images of the exact same location. One is a before image, one is after image. By that, I mean you can think of the before image as being captured in 2019 and the after image being captured in, let's say, 2024. And the idea is that we first use a segmentation model to segment out the buildings from these images. So you can see that the background is a purple color and the buildings are all highlighted using a green color. So the algorithm has been able to segment out the buildings in both the images, after which we send it to a change detection model, which tries to detect the changes between the two segmentation maps. And finally, we also have a vectorization algorithm, which converts these into vectors. Remember, I talked about vector in the previous slide. So basically, the idea is the reason we're converting it into vectors is because it's difficult to get the metric values of the size of buildings directly from pixel space. So we need it to be in the polygon space so we can calculate what is the size of the building, which is important when it comes to understanding how much of a change has occurred. So yeah, we get this output where we have all the buildings which were not there in either of the images, either one of the images, show up on this map. And this basically helped the county to find defaulters, and the extra tax dollars generated were used towards public systems like schools and parks. So this basically got me thinking about the different applications that we can extend this work to and the potential that geospatial data has. My first point of thought was we can use it for disaster damage monitoring. And this is actually already a challenge out there called SpaceNet, which you can explore. We are trying to understand before and after a disaster how much damage has been done to a building. And we also thought of like two other ways we can apply this problem. And we worked on projects on shoreline monitoring and glacier monitoring, which are coming in the climate action area. And through these projects, I was able to explore this upcoming area of climate action. And I realized that this is somewhere that my skills in geospatial plus computer vision can be applied to. Similarly, the exact same algorithm and problem can be applied to multiple areas like forest monitoring, coral reef monitoring, air quality monitoring, and so on and so forth. This made me realize that if a single algorithm can be like repurposed and applied to so many different problems, relevant problems in this space, I can't imagine the entire impact, the full impact that all the different possibilities will have if we use all the different AI algorithms out there. And that's what got me thinking about applying my skills to climate action. So the question is, why climate action now? Like, climate has always been important, but at this moment, I feel like this was a critical area and I need to pivot my career towards this. And the answer lies in the amount of destruction that we are seeing at the moment, from record ocean temperatures to wildlife population decline of 73% to ice shelf melting. It goes on and on and on and on. And as you can see, like, it's not restricted to one particular area, but it's the entire world. Some areas are more vulnerable than others, but it's still present. So the point being that the climate action is important because species are getting extinct at an alarming rate, causing a huge stress on the ecosystem. Ocean temperatures are off the charts right now, causing extreme events. Glacier melting is unavoidable, leading to rising sea levels. And top of all that, climate change is also leading to increase in diseases such as cancer, Lyme disease, asthma, etc. So this is a very complex challenge and it needs all hands on deck. It needs a solution like AI for it. But why is AI even poised to contribute to climate action now? Like, why will we say that it is more poised to handle it now than ever before? And the point is that climate data sets are huge. They're often in the order of terabytes to petabytes. And machine learning systems need a lot of data. There has never been this amount of data overflow before, and now we have this amount of data, so we can actually unleash the potential of these machine learning models. Climate is a complex systems problems, and it requires advanced solutions. AI has made significant advancements recently to tackle these complex challenges. And given the all the time in AI, we finally have access to high performance computing now, so we can actually train these models like never before to tackle these problems. So although I have described only computer vision climate action areas, you can be coming from any of these backgrounds and work towards pivoting it to climate action. One just needs to find that particular problem area where we can apply our skills to. So with that, let's pivot towards my master's in CS, because I went with all this like conviction and zeal and a particular direction in mind to get to my master's. And over there, I worked on projects on sustainability and robustness. And the question is, why robustness, right? I'm shifting from talking about geospatial AI climate action towards robustness. And the idea is that because climate change challenges are global, and if there is one area that is a sore thumb for the AI community, it's generalization. We cannot fully rely on these systems unless we know exactly where and what condition these models are failing. So hence, exploration into robustness is a very important factor when it comes to any kind of problem. So my first project that I worked on was on ML plus GIS on sustainable town planning for Henry County. So Henry County is one of those counties which is at the intersection of major highway corridors, hence creating a lot of interest for freight infrastructure development. However, as it mostly is, any kind of development does not always see eye to eye with social and economic factors. So the Henry County government, along with the community, wanted to build a tool which can be used to suggest location of development while taking into consideration social, economic, and environmental resilience. And such an approach can be taken towards multiple use cases for sustainable development. So the tool is not just restricted to these particular freight factors, but it can be repurposed for multiple developmental needs. We had several economic factors such as developmental trends, which were calculated using a customer trend detection algorithm through multiple years of development in Henry County. Accessible transportation needs were factored into it for freights to easily access the transportation so they won't cause too much congestion. And we also used future developmental goals of Henry County. And all of these factors were clustered together to divide Henry County into multiple clusters of parcels for industrial use, no development zones, and residential use. We also had social factors which were counted in, such as proximity to vulnerable populations, such as people who have asthma or other conditions which can be exacerbated by having like a warehouse close to them. Also, we took into account the proximity of schools and hospitals because we don't want freight thoroughfare in an area where children are walking or where sick people are generally have access to. And also community decision was factored into while taking into account the social factors. Finally, we also had environmental factors where we looked at environmentally sensitive locations such as floodplains, forested areas, and made sure that like those were not displaced for construction. We also had a pollution projection algorithm which tried to understand how much pollution would increase if we had a freight in that particular area and will it affect nearby communities. And finally, we also took into account traffic corridors because traffic congestion leads to a lot of pollution. So taking all these factors into account, we aggregated it into the GIS tool to finally get a tool where the community can decide on which factor mattered the most to them, give a particular weight to it, and see which parcels are most suitable for development. So with that, I moved on to my next project, which was on the topic of robustness, investigating robustness of computer vision algorithms for aerial imagery. And the main problem that we are trying to understand is how we can use synthetic data to bridge the gap that real data creates in pushing model performance. There are three main problems that come with real data. It's lacking in scale. It's very time consuming, both in terms of collection and annotation. It lacks diversity. Most real data sets won't have night conditions. They won't fly the drone in rainy or extreme weather conditions. And even if they do, it's very, very limited data, not enough to train a model on or even get insights on. So, and finally, we have viewpoint reproducibility. If you want to understand where your model exactly fails, you can't because there is no one-to-one mapping available. It's just not possible to know that a model trained during clear conditions will work well or not during extreme weather conditions. So that is why we had our data set, sky scenes, which had 60 variations for the same scene. We had 70 different images across 8 towns, 5 weather and daytime conditions, and 12 height and pitch variations. We had viewpoint reproducibility so that like each scene had 60 other variations. So you can exactly test where your model is going wrong, in what kind of height conditions, what kind of daytime, or what kind of weather conditions. And finally, we also provide multimodality so that people can explore different problems and not just be constrained to one particular problem. Compared to previous synthetic data sets, the curation strategy and the variability of data points help model trained on sky scenes to bridge the generalization gap. And not only that, but it significantly improves the performance, especially on small classes like humans and vehicles, which are the most crucial components when it comes to any detection algorithm. And not only that, but we also showed that if one has very little real data available, maybe just enough for fine tuning, treating sky scenes as a pre-training data point really boosts that performance. Finally, because of the diverse test bed offered by sky scenes, it enables model sensitivity analysis where one can test before deployment how their model exactly performs on different conditions and where it fails. With that, I like to say that SkyScenes was presented at ACCB 2024 and is open source. We have both the data that can be directly used and we have the code available for anyone who wants to generate their own variation of SkyScenes with different conditions. With that, I finally come to my current stint at Planet. And all of this experience helped me apply this towards the climate space. And that's how I ended up in my current position. So let's start with what are the main climate forecasting challenges. And one of them is climate is a complex system with many teleconnections. Traditional climate models used by climate scientists take multiple days to run. And each of these are CPU focused model, often requiring thousands of CPUs. So a lot of compute. And these are all areas that ML can help with. So be it weather forecasting or climate forecasting, it will benefit from ML. One challenge in climate forecasting is that we need to predict anomalies. We know that days will be hot in summer. So it's not enough to predict it will be hot, but what we need to predict is days when it will be worse than just a normal summer day, or days when it will be cooler than a normal summer day. If you look at this graph, you will notice that the dotted line indicates the seasonality, which means the general trend for that season, whereas the dots represent the anomalies, and that's what we need to predict well. So over here, for example, this map shows areas which are drier than normal, areas which are wetter than normal, and not just giving us a direct temperature value. So predicting anomalies in climate conditions is important. Another challenge that comes with climate forecasting is that climate systems are probabilistic. If you have seen weather news, you will notice that there's a probability associated with how the weather will be. It mostly says that, oh, there is a 15% chance of X millimeter of rain between 2 to 6 p.m. on Friday. It doesn't just provide an exact value on the amount of rain the city will receive, but a probability that rain of this intensity might occur. So it has to be a probabilistic forecast and not just a deterministic one. And finally, I would like to say that at Planet, we are focused on medium range forecasting, which is in the range of 7 to 30 days and is very, very hard. If you look at this graph, you will notice that for timescales less than 7 days, the predictability is mostly defined by the atmospheric conditions, whereas for timescales beyond 30 days, it's mostly the ocean. Whereas timescales between this 7 to 30-day period rely on interconnection between the atmosphere, ocean, and land, making it a very, very complex problem, which is further made worse by the unstable behavior of land variables owing to the effect of human activity. So ocean variables have a very strong influence on land variables and vice versa. So how can AI help? How should we think of climate modeling? Well, we have as input multiple variables for each point on the globe. And we have multiple such globes representing how the variables look like at every time step. This input is fed into a machine learning model, which then predicts how these variables will look at, let's say, time t+1. And then we feed it back to the system and generate multiple rollouts to get predictions for multiple weeks, months, and years. This is one way to think of such modeling. You can imagine the Earth through time as a complex video with multiple channels. One important factor to keep in mind while designing these machine learning model is that it's not just local interconnections that matter, but also global. And while in the case of a video, local interconnections might mostly be of higher importance, same cannot be claimed about a climate model. Also, another point to note would be that ocean variables, atmospheric variables, and land variables are strongly interconnected and will be influenced by each other. So how do we design a model that takes all of this into account? This is a problem that many of us are currently working on to solve for medium range forecasting. A lot to think about and a lot of open questions out there and a lot of space for exploration. So with that, I'd like to conclude by saying that climate change is the problem of our lifetimes and the time to take action is now. And there are a lot of challenges out there like the one I described in my previous slide, where AI can really make a significant difference, and a lot of problems that are still very open-ended and very exciting. So be creative, collaborate with domain experts to solve some exciting challenges. And finally, I would like to talk a little bit about my challenges with climate job search. So how to build connections within the community. So for building connection within the community, I will strongly recommend Slack channels. Slack channels are a great way to connect with the community, find people who are working on the same things as you. There is the AI for Conservation Slack, which has a lot of members, a lot of experts from all over the globe on there. There's Work on Climate, which is another good Slack channel where you can find a lot of opportunities, jobs, different talks, and also collaborate with experts. And of course, following the right people on LinkedIn will expose you to the right kind of climate news out there and keep you up to date on what's going on in climate. And also Twitter for any kind of climate research. If you want to work on side projects, Climate Base actually has a very good fellowship program that I have not done personally, but I've heard a lot of people recommend. And Climate Change AI is a good forum if you have like some idea, if you want to present your work in a workshop. Climate Change AI hosts like these workshops at some of the major AI conferences. And it's a good way to get into this field and meet some of the experts out there. And finally, some climate-specific job boards that I have linked over here. So yeah, thank you, and feel free to contact me if you have any questions. Oh, I see.
Yes, ma'am. Ramalada ma'am, I would like to call Ramalada ma'am to have a question answer session, please.
Yes, I was
Yes,
actually talking, but there was also some background noise.
yes, ma'am. Yes, ma'am. I actually put the questions on the chat box, ma'am. I taken from the
Oh,
YouTube and I
okay.
posted. Yeah.
Yeah.
Should I reply on that URL?
No.
Oh,
The questions are in the chat box, Anisha.
okay.
You can choose any question first, you can answer. I think the first question actually is the question from the YouTube, Kanagaraj sir, because I find that whatever Anisha explained aligns with the answer to the question. Anyway, I'll leave it to Anisha.
Yeah, I think I covered that part towards the end, where my work with like climate change challenges. So one of the main challenges that is there is like forecasting. So for any kind of problem, like be it like trying to understand, how the agriculture output of certain things will be, it lies in climate forecasting. If you don't know what the weather tomorrow is exactly going to be like, you cannot grow certain things because, they might get damaged if too much rain comes, too much hail comes and all of that. And there are also challenges in terms of like how forestry companies view, where they need to know what exactly the rainfall patterns are going to be like if they want to replenish the forest, because there can be like heated days and wildfires might come. And so they need to be prepared for that. So climate forecasting is the starting point to trying to solve any of these challenges. And it can be like extended to multiple such climate change applications. So I think that's how my work at at Planet AI is aligned with the climate change challenges out there. I hope that answered the question. If you have any further questions, please feel free to reach out to me on LinkedIn as well. Yeah. AI transforming over the next decade. So it's already transforming a lot, and already a lot of experts in this field of like computer vision, for example, are actually transforming towards the AI for science direction. The reason being that we have made a lot of leaps and bounds in computer vision, in AI, but what we need to do now is take that problem and apply it to solutions like climate change, like drug discovery, and all of these areas, which really need that acceleration. So, yeah, I see a lot of transformation having like climate action strategies. In terms of like policies and stuff, so a lot of these AI chatbots are, so policy documents, for example, there is one application that I know of, are extremely long. So these chatbots are actually helping like condense the policy documents into like specific forms, which help policymakers to kind of understand what is the exact gist that we are getting out of this particular document. And it can also suggest that ways to make it more convincing so that the climate policy is accepted by people. So that is one area where it can directly help policymakers. Data challenges faced in implementing machine learning models for environmental applications. There's a lot of data out there, but it's not clean. So a lot of the data processing that goes into it, data cleaning, it's a big pipeline that a lot of people don't talk about. The AI modeling part of it actually like comes way later. Before that, we need people who have domain knowledge, like climate scientists, to be able to like decipher, okay, is this data even useful? There's a lot of sparse data as well. Like you might not get data from a lot of points around in the earth, so you have to like interpolate those data points as well, or kind of try to like make the most of the sparse data that you have available for some particular variables. So there's a lot of this challenge that generally goes on when it comes to machine learning models or a lot of environment applications. In terms of ecology, I'll say there's like this problem where people are trying to use camera trap images to detect animals. And the problem there is the quality of the data. Most computer vision algorithms work with high resolution imagery, but whenever you try to work in the real time with camera trap images, it's very low resolution imagery. And trying to like get these models to work with these kind of like images on a real time basis is a very difficult task. On top of that, most of these images are captured at night or in like not very favorable weather conditions. So again, the question of robustness comes into the picture. Oh, I think I already discussed the how can governments and policymakers leverage AI tools in my answer to one of the previous questions. Interesting research directions in ML for climate action. As I mentioned, there are a lot of different areas. If you're interested in physics-informed machine learning, there's a lot of work going on specifically in the forecasting area, or trying to model the Earth in different formats, trying to capture what like the ocean looks like, trying to capture what like the land, predicting what the like how different temperature variables and other variables are changing through time. So that is like one specific area where physics-informed machine learning models can be very useful. If you are interested in natural language processing, well, there was one project that I did not talk about because we're running out of time. But for example, GenAI spread is leading to a lot of spreading of misinformation everywhere. And it is also affecting the climate world because climate is already a sensitive topic. And on top of that, if you add misinformation, you are kind of like making the public think in a different direction than you want to actually get those climate policies accepted. Or sometimes you want the election results to like come in a favorable outcome so that the policymakers are supporting climate change. And a lot of times GenAI is being used to manipulate or change election photos and other stuff. So one way you can think of is how can we develop like natural language processing tools to detect this kind of like misinformation that is being spread. And that can be applied towards climate specific problems. And regarding computer vision, I think I shared a lot of those possible areas that one can work on. Yeah. I'm open to any other questions if there are more.
Yeah, I have a question, Ansha.
Yeah.
See, you have described about the different tools that are available for identifying the climate change, but what kind of actions are being taken, or what kind of actions are possible through AI for mitigating climate injustice? You know that in different countries, especially the indigenous populations are the ones who are affected by the climate changes. Uh, any underserved person, I would say. So that kind of injustice, do you think your AI model will be able to indicate and solve?
That's a very good question, actually. So, in my experience till now, since at this point of time, we are just like transforming from a place of full AI to applying AI for climate. Most of this is, yes, being applied to the upper stratas of society and not really taking into action the indigenous populations and stuff. So what we need over there is we need to basically try to understand what their goals are aligned with. And right now, I think, for example, like salt mine workers, so they are basically trying to like salt, like their lives are very much affected by the how temperature and weather is changing. So we can use something like climate forecasting to forecast like how the rain is going, when is the rain going to come, and all of those factors. And that can be useful for them, like giving them that weather information, because that will help them plan their livelihood. Or farmers in India can, like, every year flood comes and a lot of farmers lose their livelihood. So if there is a way to like get this data available to them, then they will know how to go about their planting strategy and all of that. But for that to happen, we need a connection between people like us who are working on AI and people who are on the ground who can go and give this information to farmer. So that link needs to be made for AI to be actually be useful to people on directly working on things.
I agree. And one more thing is, whatever you described is an immediate solution or immediate impact. For the long run, for maybe for the future generations, for the AI to have an impact on the climate injustice, probably we should have a collaborative effort towards this also, because the groundwork is being done, but of course the collaborative effort only is going to help the long run.
Yes, yes, that is completely correct. And yeah, right now that because yeah, right now people are just transitioning from AI to AI for climate. I think it will take a few years for that full collaborative effort to work. And there are organizations like the Slack channels I mentioned, AI for Conservation Slack, where people are trying to work with direct like policymakers, directly trying to work with ecologists who work with people who are working in this national parks and stuff to get those to solve those problems. But that's a long pipeline that's in the works, and hopefully we will see positive changes. Yeah.
Are there any other questions? Did we get
And that's all, ma'am.
that's all?
Okay.
Yes. Thank you, Anishapal. So I would like to give a word of thanks. So a very good evening to everyone. So I am glad to be stand here to express my vote of thanks. A special thanks to our chief guest, Ms. Anisa Paul, scientific ML engineer, so for accepting our invitation. So and sharing your wisdom. So your thoughts have truly inspired us. Thank you, ma'am. So I heartful thank to moderator Dr. Ramalada Mahnimuthu ma'am, the founder of IExplore Foundation for Sustainability Development. So for your continuous support and guidance, thank you, ma'am. So a special thanks to our mentor Dr. L. Ramesa, so president of IGEN, so for assisting us in making the event success. So a sincere thanks to convener Dr. Agila Mudramlingam ma'am, secretary of IGEN. So for making this event a great success. Thank you, ma'am. So finally, I would like to thank to all the participants who made this event a memorable one. So thanks to all. So have a great evening. Thank you, ma'am. Thank you for all.
Thanks a lot. Thanks for having me.
Really very nice, ma'am. So definitely we have touch with you that regarding the DML and other things.
Yeah, sure.
Yes, sure. Thank you for that.
Thank you, Anita. Thank you.
Yes.
Thank you, everyone. Bye. Have a
Thank
nice
you,
day.
ma'am.
Bye.
Thank you for adjusting your sleeping time. Okay. Thank you, Kanaraj.
Thank you, ma'am. Thank you, ma'am. Actually, the feedback link is not posted, ma'am.
Okay. Okay then. Okay.
Varun? Varun or Nikhil? Varun or Nikhil, are you there? Okay, ma'am, I will confirm and I will close it, ma'am.
Okay.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Sir, thank you, sir.
Abhi, are you there? Yes. I mean, we will close it within 2 minutes. We'll wait the Google form will share to all. Then we'll close. Okay. Hello.